Hi folks, this is the seventh problem of the DSA series. So without any further delay, let's get started. It says you are given a 9 by 9 Sudoku board. A Sudoku board is valid if the following rules are followed. Okay, so this is a 9 by 9 Sudoku. Let's see what rules should apply. Each row must contain the digits 1 to 9 without duplicates. Each row must contain the digits 1 to 9 without any duplicates or without any repetition. Okay. Each column must contain the digits 1 to 9 without any duplicates. Each column contains digits from 1 to 9 without any duplicates. Okay. Each of the 9 3 by 3 sub boxes of the grid must contain the digits 1 to 9 without duplicates. So there are 9 sub boxes. This is a 3 by 3 sub box. This is a 3 by 3 sub box. This is a 3 by 3 sub box, and so on. Each sub box should contain digits from 1 to 9 without any duplicates. Okay. Return true if the Sudoku board is valid, otherwise return false. If the Sudoku is valid, we should return true, else will return false. A board does not need to be full or be solvable to be valid. A board doesn't need to be full, right? So all of these boxes need not to be full. Whatever is there, we'll work with that. We'll only see whatever numbers are present. We'll only work with those, okay? We only see they don't repeat through the row, through the column, through this grid. Okay. Okay, now yeah, so this is the example. This board there's no repetition, hence output true. In this board there is some repetition, hence output false. The repetition is this. You see this 3 by 3 grid, this 1 2 and this dot, this 4 dot 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 9 1. Here 1 and 1 is being repeated in this 3 by 3 grid. That's why the output should be false. Okay. And one more thing, the places which are empty, we'll place dots there. Okay. So let's get started. Let's write a function is Sudoku valid. It will take a board. A board will be nothing but this array of arrays. Okay. So this array which will contain the 9 arrays, each representing individual row. This is row 1 representing the array 1, row 2 representing array 2, and so on till this row 9 representing array 9. Okay, array 9. Okay, so yeah, so let me brief you the strategy that I am thinking of. So we'll take 3 sets. Okay, so we'll take 3 sets. Set is a data structure similar to an array where repetition is not allowed, where each element is unique. Okay, so we'll take a row set to examine rows. Okay, we'll take a row set and add 7 in that row set, 1 in that row set, and if let's say 1 is being repeated, we won't be able to add in that row set. Okay, so we'll return false because there is repetition in the row, and we'll do this for each and every row. Okay, if there is any repetition, since set contains unique elements, we can't add anything. We'll check if that element is already present. If it's already present, we'll simply return false. So this is a row set. Another is will be the column set, and the concept is similar. Will again, in the column set we'll check this, and okay, 4, we'll add 4, and if again the 4 and we encounter 4, we'll check if 4 already present, that means return false, else no worries. Okay, so again we'll check each and every column, okay, in the call set. And the third is the grid set. In the grid set, we'll check each of these 9 grids. So we'll add these elements in the grid one by one. If any element is being repeated, we'll return false, else we'll return true in the end. So let's get started, and you will understand better. So let us write a loop for let I equals to 0. First concentrate on the rows. Okay, we'll iterate through these rows, row 0 1 2 3 4 and so on. Okay, I should be smaller than 9. Here we have this constant 9, I plus plus. Now we can say let row set is equals to new set. You understood why we took set, right? Because set contains unique elements and we want to find duplicates, right? So let's say row set, let's say call set, new set, and the third one is a, let's say grid set, new set. Okay, now now let's run another loop for j equals to 0, j should be smaller than 9, and j plus plus. Now we'll say const, let's focus on the rows first. Okay, we'll check each row one by one. Row key is equals to board I j. Okay, so row key. Okay, so row key, so in the I will check, so yeah, so first row key will be this 0 1, whichever the element, sorry, whichever present element will present 0 0, then another will be 0 1 0 2 0 3 0 4 and so on. Okay, so this will give us the row key, okay, for this first row. Then in the next I will get the row keys for the next row. Okay, so this is the row key we get. We'll check if row key, not row key, if row set dot row set dot has row key, if row key is already being present, we don't want to add duplicates, that means this is a duplicate row key, return false. If this is not the case, we'll simply say row set dot add, and yes, we'll use add to add an element in the set. In case of array we use push, right? Yeah, so we'll add row key if it's not present, as simple as that. Okay, so this row key will check this row. Then again, when we come to this row, the second row, the row set will be a new one. Okay, so when this array will iterate again, this row set will be again reset, will be again be new one. So yeah, we'll again make this row set and check while making. If it's present already, then simply return false. If not, then simply add that row key. Okay, now one more thing, other than these elements, there I said that we have dots in the empty boxes, so we'll check for that as well. We'll see if row key is equals to dot, or we should say if it's not equals to dot, then only do this, else no need to add anything in the set, right? Okay, so this is for row. Now we'll do a similar thing for call set, for columns, to check the columns, j plus plus. Okay, so in this case, since we are doing for columns, this will be reversed, ji, and here I'll make you understand why I reverse this. Let me first do it. Instead of row key, let's write call key. Instead of row set, let's write call set, call key. Okay, okay, so yeah, here the iteration will happen like this, this is the first call set, second call set, third call set, and so on, right? So yeah, so hence this will increase, no? So this will be 0 0 1 0 2 0, so j will increase. So we have put j first, right? The first index will increase, because 0 0 1 0 2 0 3 0 4 0, the first one is increasing, so we did ji instead of ij. Okay, and then in the next, in this next, if the I changes, will come here, and then again j will increase, I will remain constant, which is 1 throughout this. Okay, so that's why we switched from ij to ji. Okay, now this we checked for row, we checked for call, let's check for grid. So for grid, let's say, mm, okay, so let's do this 3 by 3 grid. How to check this 3 by 3 grid? We can simply have two loops, two nested loops, that is one inside the other, checking this 3 by 3 grid. Okay, then afterwards we'll see how we can do this for all the grids. Okay, so first let me write two nested loops which run for 3 times each. Let, not ij, let me call this mn, m equals to 0, m smaller than 9, m plus plus, then here again we do for let n is equals to 0, not 9, actually 3 because we have 3 by 3 grids, right? And we map through the whole grid. So this is row, this is called n plus plus. So this is how we'll map. Okay, so this will map through the whole grid, but let's say this grid is completed, we check this grid, then we have to move to the next grid. Okay, I'll make you understand how to move to the next grid in a bit. Well, first map through this particular grid. Okay, a single grid. So here we'll check the same thing, we'll do the same thing, that is we'll say grid key, let's call this grid key is equals to board m n. So instead of, if grid key is not equals to this dot, then in the grid set, a set can be like this, no, with individual elements, okay. So grid set, we'll check if the grid set contains the grid key. If it does, then we can't add another one, hence return false. Else simply add the grid key in the grid set. Okay, so for this we'll have a set of, like we'll have a set, okay, which we'll add, we can add maximum 9 elements in the set because there are only 9 ones in here, but the dot, the elements where we have dots, we won't add those. Okay, so yeah, okay, so yeah, grid set grid key. Okay, now this is for the one grid only. How will map over all the grids? There are 9 grids in total. So for that what we can do is, so I did something. So what I did is, here I did this. So let me just copy this. So I'm doing this, it's very easy, it's very simple, but yeah, I'm doing this so the video won't be much longer and you understand the issues, like how I'm doing things. It's very easy, right? Like instead of m and n, let me write start row, and yeah, we can do start row and start. Okay, so yeah, so okay, so here we can write let start row and start call. Okay, let's declare these. So what I mean is, here we'll have start row 0 0. Okay, this grid is starting from 0 0. This is starting from 0 0 3. This is starting from 0 3 if I equals to 1. Okay, when I equals to 0 initially, so we are in this loop, right, in this bigger loop, in this I loop, which is looping 9 times. So we'll want to loop like in 9 times. Each time we want one grid. Okay, so when I equals to 0, we have 0 0, we'll start from here. When I equals to 1, we'll have start from here, where m is 0, n is 3, m is 0, n is 3. When I equals to 2, we'll start from here. When I equals to 2, we'll start from here, where we have 0 and 6, 0 and 6. Okay, then when I equals to 3, we'll go here, I equals to 3, then we'll start from 3 0, we'll start from 3 0, 3 0. Okay, and yeah, so this is again another starting, this is again another starting, this is again starting, again starting, again starting, the nine starting points. Okay, So instead of writing in this way, we can simply do this. Simply say, okay, let me do this. Start row equals to match dot flow this, and start call equals to this. It will give us the correct combinations. Okay. Now instead of m equals to 0, we'll start from start row and do m plus plus. Instead of n equals to 0, we'll start from start call. Start call and okay, so here we do start row plus 3, start row plus 3, because we have to map 3 times. Start row plus 3, here we'll do, you understood, no? I did this logic. Like, you can check what start row and start call will be for I0, I1, I2, I3 till I9, and then in the end you'll come up with this. You can easily do it by yourself. Okay, so yeah, everything seems to be fine, and this should work. Let me see. Okay, so let's see if things are working. Console.log is Sudoku valid, and here we can simply board one. We do board one, and it should return true. And it is returning undefined instead of true. Why is it so? I don't have an ounce of idea. Grid set, row set. Okay, here we are adding the row set instead of call set. Okay, let us do this one more time. We are again getting undefined, and that's freaking awesome. Okay, it's true, no? So yeah, so here we are returning false, but we are nowhere returning true. So in the end, if the loop finishes and we won't return false, that means nothing is being repeated, and hence return true. Yep. Yeah. So see, this return true, and this should return false. This board 2 should return false, because there is a repetition in the first grid. Yes, it is returning false. So yeah, this is the 7th problem. I'll push it to my git, and you can check it out from there. Thanks for watching.